Hello everyone, so this is the continuation of the previous video, and in the last video we talked about boxes, robots and variables and things like that, but in this video we'll just expand on that. It's not something that we're going to totally change the course of the direction that we're going. We're just going to stick by the names, because I'm a staunch believer in the basics. When you understand the basics, well, everything will go very, very smoothly. So what are we going to do here? We had some lines, we wrote little programs where we calculated by doing plus and minus certain numbers. But something that people have noticed is, that probably noticed, and probably the programmers who are more experienced have seen it and they've gotten a headache by now, is that sometimes I've been capitalizing the variable names. This is a common newbie mistake. It's not something that people usually do or like. Capitalizing is a big no-no most of the time that I've seen. I'm not sure because I've never been in huge projects. It's just been personal projects of mine that I did. But yeah, generally names are kept lowercase. For example, let's write heat radiators, okay? And we have 7 heat radiators. But if we write it like this, and it's 8, why don't we get an error message? Because these are 2 different boxes altogether. This means that the names of the boxes, the names of the variables, are case sensitive. And the thing that is the case here is that we cannot have 2 boxes with the same name. If we write it down like this, heat radiators and heat radiators, what happens is the first one, where an object with a value 7 within it, is exchanged by a second box. This one is thrown out to trash, and the second one is replaced with an object inside of it that is with the value 8. So we basically are overwriting the previous value by putting the same name. But if we want to differentiate between them, we can write an extra S here or something like that, or a number. First one could be the heat radiators 1, the second one is the heat radiators 2. Basically, all you can write in the names in the variables here on top of the box are names that are connected with underlines and the numbers and letters. Numbers, letters, and an underline. So that's the thing to keep in mind. The variables and boxes are also case sensitive. Right now we have 2 boxes with 2 different names because one has a big R, the other one has a small R. This is something to keep in mind because you might make a mistake where once you write bananas and the other time you write bananas and you don't see why it's not print bananas, and you don't get it, why isn't this working or whatever like that. It's just because you forgot to check if it's lowercase or uppercase. So that's something to keep in mind. The names are upper and lowercase sensitive. You can write numbers in it. And also the third thing that you should keep in mind is that they can be as long as you want. So the variable names can be as long as you want. Please just keep them short. The shorter, the better, because then it will be tough to differentiate between variable names. So yeah, okay. But I bet everyone who watched the first video, so the previous video, has gotten their time off and just experimented with it, and then they had the genius idea of what happens if, which I just explained earlier, I change the name. So we have a box named A and has a 4, and we write again is equal to 6. You can make the spaces after the equal sign, it doesn't matter. Usually people do it, and I would like to do it like this too. Why? Because it looks very more pleasant to the eye. And now we write print A. Okay, very tiny program. So there is a box, number 4. We said it's overwritten by 6. Now we want to print it. And let's check what it says. It says that the A is equal to 6. Okay, good. So the last value is the one that is kept in mind. Great, 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 great. But what if we delete this and we write it here? So logically, the second variable A is the real value because it's overwriting the first one, okay? But let me check. It's 4. Why? I would like you to take a minute and think about that. You can pause, but it's pretty straightforward. It's the same case like I explained earlier. It's that the computer is dumb. It goes linearly from top to bottom. And as it goes like that, from top to bottom, it checks like this. Okay, so it's the first line, it's A is 4. Then we're telling the computer to open the box named A, and it sees there is 4, and then keeps it in mind, okay? And writes down that to the computer. And a second after that, the third line says, A is actually 6, so the box with the name A has a value of 6, but that doesn't make it to the computer because the computer checked beforehand. So it's printing out the value that it checked for earlier. So if in order to rectify that, we can also say print A again, and when you run it, it prints 2 lines because the first one is printed after the first value is 4, and then the new value is written here, it's 6. Okay, good. I think we got a good grip of this one. But let's do it like this. It's basically the same thing. AA is equal to 4, BB is equal to 7, and AB is equal to AA times BB. Okay, good. So when you check that, what would it be? It will be 4 times 7 is 28. Okay, let me check it. Great, it works as intended. But let's try and write down here, BB is equal to 9. If BB is 9, then 4 times 9 should be 36. Let me run it. Nope, it's still 28. Why? What happened here? What happened here is the same as before, because the robot in AB is doing the calculation with the pre-existing values that are in the boxes. So after the calculation is done, then it is stated that BB is actually 9. So it doesn't get to recalculate. It's the previous calculation of the robot that gets to be printed. Okay, so let's take it one per one in the line. AA is 4, BB is 7, AB is 4 times 7, which is 28. That is actually BB is 9, but when this calculation was done, it was 7. So the initial value persists and it's written in the end. Okay, but people will point out that maybe this line of thinking is not so good. Let's think of it in terms of boxes. In AB, there is this box with a tiny robot. The tiny robot does the calculation, has the 28 in its hands, returns to the box of AB, and now this AB box has the value of 28. Okay, so it doesn't matter much what happens with AA and BB afterwards. It doesn't really care. It just keeps in mind that its value is 28, the same as the first time that we calculated it. Good, so that's something that we need to keep in mind, that this linear fashion of thinking is very, very important. And if you want to change some value before a certain calculation, you should change it upwards, not in the end. You can't just do it here and then think that this upper calculation, which is 2 lines up, will rectify that thing that you thought. The computer cannot guess your intentions. It just does linearly from top to bottom the calculation. So this would be the part that I wanted to discuss. Here I've written something. Yep. So, okay, this is a great example. Let's check this one. Okay, good. So in this question, I wrote B is equal to question mark. Let me find where is the hashtag. Okay, good. Hashtag turns lines into comments, and this doesn't get processed in the code when it's run. So we have A is equal to 3, B is equal to A, and A is equal to 4. What is the value of B if we write, for example, print B in this case? What would you guess? So A is 3, B is the same value as A, and A is then 4. Does the value of B change? No, because B takes up the value when at this moment A exists. At this moment, the robot in the box B goes to the box A, checks it, and says, okay, it's 3, and I will be 3 as well, and returns back to the box. So B is 3. And will it change the value? Let me check. And no, it doesn't change the value, because what happens with A afterwards, after the tiny robot checks the value of A and assumes that value, it doesn't matter what happens with A afterwards. It's just that linear fashion of thinking that I talked about earlier. This is in green because it's the hashtag turned it into a comment, and it doesn't interact with the code at all. So we discussed names can have letters, variables, numbers, or underscore, and can be case sensitive and vary in length. But there is a whole ton of different types of variables, of objects that are within those boxes that we are calling variables or names or whatever. We have integers. Integers are numbers, the ones that we used until now. Then we have floats. Then there are strings. Then there are booleans, and then there is actually the none type of object. What we will concern ourselves with is mainly with integers and floats in this video, and then we will go the other ones in the next video. So let's check. We said we're gonna do floats. Floats are types of objects which are numbers, the same as integers, but they have the decimal point. So if A is equal to 2.0, then this isn't an integer anymore, because integer is rounded numbers without the decimal point. It's a float. It doesn't matter if after the point it's a 0, or if it's a 1, or if it's 91 or whatever. As long as it has this dot here, this decimal point here, the type of the variable A is 2.91. Print type of A. This is just a command to tell it, please tell us what kind of object is within the box called A, and it will tell us. Let us check, and it says this is a float. But if we make the point go away, Let's check it now. It will tell us it's a integer, okay? So this is just a little command to check what kind of type of object is one certain object. Yeah, so what happens if we add an integer with a float, okay? The result can be 291 plus 13.3 is 304.3. So we can guess that it will be a float, okay? Sum AB is equal to A plus B, okay? Print sum AB. Sum AB. So we're going to tell the computer to print the sum of these numbers, and it's 304.3. We have the decimal point here, so we can assume that we know that this type, okay, of sum AB is float, right? Let me check. Is it a float? Yes, it's a float. Great. So we got it. But what if we make it a 13.0, and now when we add everything together it's 304? So the 0.0 is negligent, right? So if it's just 304, it should be an integer. So let's check sum AB, print sum AB. Do we want the type? No, we're just gonna do, we're gonna do type of sum AB. It's probably better this way. It says float, but why? We just found out it would be 304. So in order to check why, let's say to the computer, please tell us what is the value of sum AB. And we see it's running, it's 304.0. So any type of calculation that is done between an integer and a float, okay, float is a number with a decimal point, it will turn to be a float. So that's the thing here with floats and integer. The way they interact with one another is the same as just integers. It's just that the type of object changes. So this is something to keep in mind, and it will be important in the future. So we'll stop here, and in the next video we'll go into details with strings and other types, and confuse it a little bit more, because I like for it to get more complicated as we go. So that's it, and bye.